say, you know, a woman's never supposed to tell her age. I am turning 50 in less than, 5 months? So this, yes, my 50th birthday is June 6th, so I'm like, I cannot deny anymore that, like, yeah, this is a new section, a new phase of life, right, that we enter into. And so I'm thinking, I need to biohack my brain right now and figure out how to do it. So I decided to talk about the glymphatic system tonight. It's a system that maybe a lot of people are not as familiar with because we all kind of have a little bit of knowledge about what our lymphatic system is, but not necessarily our glymphatic system. So I'm going to talk about that in just a second. We just have a few more tickets to give out. So that's the lovely graphic. When I found that graphic, I was like, okay, I'm going to talk about this because what a perfect graphic for clearing the waste out of your brain. Okay, so here we go. So remarkably, like when we think about this in terms of how recent an actual discovery this lymphatic system is when we think about medicine and we think about science and we think about neuroscience, the lymphatic system was only discovered in 2012. So it's really only been known, and the research on it is just, really expanding these last few years. All of my slides with the references at the bottom are at like 2018, 2017, 2019, 2020, 21, 22. That's how recent the research is, and there's just so much out there to learn about this. So the lymphatic system is in the brain, and it's basically, these are just some of the ways that you can see and visualize the glymphatic system. So when they study it, they look through things like this, like 2-photon microscopy, various types of MRI, some diffusion tensor imaging, and again, these are all just ways that you can look at your brain, PET scans, SPECT scans, and see what's going on. So they're able to sort of see, when we get into a little bit of the research in a minute, these are some of the methods that are used. So what the glymphatic system is it's a waste clearance system, and its main job is to remove misfolded proteins, toxins, and waste products called metabolites, and specifically like amyloid beta, tau, and alpha-synuclein, right? And so why should we care about those three in particular? Well, the buildup of amyloid beta and tau is implicated in Alzheimer's disease, and alpha-synuclein builds up in the brain in Parkinson's disease. Okay, so those are neurodegenerative disorders, and all of us here would like to do our best to try to decrease our risk, right? Reduce our risk. So the glymphatics also remove some other things in the brain, potassium, lactates, and soluble proteins from damaged cells. So once cells become damaged, they start to, like Chelsea was talking about, autophagy, why we want to purge them out. They start to release inflammatory chemicals, so we want to get rid of them, right? And aged astrocytes in the brain, that's what senescence means. Also, they found that it actually it's getting rid of one set of things, but it also might help distribute glucose, amino acids, lipids, and neurotransmitters in the brain, like your serotonin and your dopamine. So just to look at this slide, we're not going to go too deep into it, but just to sort of see, this is a way that it works. So the cerebrospinal fluid comes into the brain, and the influx of it comes in. That's a cerebral artery right there, so an artery in your brain. And then this kind of visualized area around it, that is the glymphatic system. It's in the space around the artery. It's made of astroglial cells. The purple ones are neurons, and the astroglial cells are shown. They're kind of trying to surround that, right? So this fluid comes in, and it's dependent, its transmission is dependent on aquaporin 4, which again, we're not going to get too deep in the biochemistry of that, but that has a polarization, so it kind of it helps to mix it with the interstitial fluid of the brain and make it spread. So then over here, as it does that, right, now let's see that with little waste products. Well, that fluid, this system, is supposed to pump that out of the brain, which the veins, the cerebral veins in your brain, are the ones that are like, it's kind of move moving it out through efflux, which is carrying it away, and then it drains into the lymphatic system and into the cervical nodes, lymph nodes, and then endpoint to the liver. So when we think about Alzheimer's, how is the lymphatic system important? Well, amyloid beta, this is this peptide, right, and its deposition has been found in the brains of Alzheimer's patients. And so it accumulates extracellular, so outside the cells, and it forms these plaques. And everybody's probably heard of that, right? Plaques in the brain with Alzheimer's. But the thing is, there's an opportunity for those to be removed, for the amyloid beta to be removed from the brain before they start to aggregate into plaques. So this happens, this removal happens via the lymphatic system. So we obviously want to, kind of understand it and see what we can do. Is there any way we can promote its function? So unfortunately, just the mere fact of aging, the function of the lymphatic system declines. And they say by about 60% through our 50s. So that was not good news for me. But if we can learn a little more about it, then it can prove to be a promising therapeutic target to help us curb the buildup of this toxic waste and help potentially prevent cognitive impairment. So that's one type of dementia, right? Alzheimer's dementia, these amyloid plaques, that's one type. And the lymphatic system, we just said, is really important in helping get that amyloid beta and that tau out of the brain. Now, there's another type of dementia that's called it's related to small vessel disease in the brain. This is more about the arteries in your brain and how they basically get clogged up, let's say. Okay? So in order for this lymph system to work properly, the spaces around those arteries has to be healthy. Okay? And then what happens is one of the ways that those spaces are changed is by hypertension, diabetes, and chronic inflammation. So obviously anything that we can do to reduce the risk of diabetes, hypertension, and chronic inflammation is going to help us then is going to help those spaces be what the lymph system needs to function properly. So this dementia, the small vessel disease, right? So basically when those spaces get too large, then it slows down the lymphatic function. Right, so we want that system to be working good. We want it to come in, we want those waste products to be efficiently removed. We don't want it to sit there and stagnate and slow down. Okay, so when we look at this through a functional medicine lens, many of you know that's really what my primary focus is these days. So we look at, this is a functional medicine matrix, and this is with my training is mainly through Institute for Functional Medicine, so they're the gold standard in functional medicine education right now in the United States. So when we look at this is kind of how we take a case, if you will, or look at someone's situation and we try to map it out. So you have on the left like antecedents, this is like things that came first, triggering events, and mediators and perpetrators, what keeps your symptoms going. And sometimes there's a mix between triggers and mediators, and something can be both. And then we look at these nodes, and in functional medicine, we're not breaking it down into organ systems. So we're not saying like your liver, the digestive system, your heart, cardiovascular, lungs, respiratory. We're not looking at it in terms of organs, we're looking at it in terms of function. So when you see defense and repair, right, we can think immune system, but the gut barrier has to also defend, and the blood-brain barrier also has to defend. Right? So we look at energy production, biotransformation, elimination, transportation, communication, so signaling, structural integrity of things, and assimilation. So when we look at that, and then in the middle, I love that IFM puts the mental, emotional, spiritual, because really, truly, that's what's driving so much of this. But down at the bottom, we pay a lot of attention to what's called the modifiable lifestyle factors. And why that's important is because those are the things that you have control over yourself. This doesn't need a practitioner or a doctor or anyone to help you with these things. You may need some advice about them, but these are things that you can do on your own. You can modify your lifestyle in a way that promotes health instead of disease. So I've started the 4 things at the bottom that I'm going to highlight tonight when it comes to the lymphatic system and looking at that through a functional medicine lens. So sleep and relaxation, exercise, nutrition, and stress. So sleep, here's what's super important. If you remember one thing about the lymphatic system, remember that it functions almost exclusively during sleep. So especially it's turned on during stage 3 sleep, which is non-REM sleep. You spend more time in that in the first part of the night. And this is where your delta waves, you have delta wave sleep. So the glymphatic system is 90% reduced during wakefulness hours. So you're not really clearing a lot of stuff during wake. It happens during sleep. So automatically, you guys can see where I'm going with this, right? If you're not sleeping well, then your glymphatic system is going to be impaired, okay? So this is interesting too, that they've discovered that the glymphatic flow, due to the effect of gravity and the way it functions, that the flow is optimal in the right lateral sleeping position. So a lot of patients with Alzheimer's dementia have been found to spend more time sleeping on their back. And that's not ideal for the glymphatic flow, right? So just something very simple, trying to sleep on your right side or train yourself to sleep on your right side could be very helpful. So dysregulated sleep is also a symptom and a contributor to Alzheimer's and Parkinson's. We just mentioned that. So if you have poor sleep, you have reduced clearance of this metabolic waste, and about 40% of that amyloid beta peptide that we talked about is cleared during sleep. That's a lot, right? So that amyloid beta that builds up in the brain and forms plaques in the patients with Alzheimer's dementia, 40% of this is cleared during our sleep. So we definitely want to make sure we're optimizing sleep. Chronic insomnia patients had higher levels of amyloid beta in their cerebrospinal fluid than normal sleeping people. So even, that's just chronic insomnia. That's not Alzheimer's. Okay. There we go, exercise. So this is a mice study, but basically in this study they showed that voluntary exercise accelerated the efficiency of the glymphatic clearance in aged mice. So what's interesting about this is in research, they have these mice that they have given Alzheimer's, like let's just say it for lack of better terms, that they've made develop symptoms and brain changes that are consistent with Alzheimer's dementia. So they make these mice and they use them for research, okay? So when these mice were given the opportunity to run on their wheel, and then at the end of this study, they looked and they found that they performed better on the water maze test, which is it's like the test that they use in research for mice to assess their cognition. I had a funny thought about this. There was one, okay, I have to say it. So there was one article I read, and it was out of a Chinese journal, and we'll get to that one at the end, but I have to say it now. So they literally were like, it was like the Chinese don't mince words. They were like, these mice were tested in the beginning, and the ones that were removed for the water maze test, if they were too sensitive, or I quote, too stupid. Not even kidding. I was like, wow, okay. Stupid mice, get out of here. Okay. So anyway, this water maze cognition test is very much like they have to learn how to get through a maze, and they time them and all that kind of stuff, right? So when they had exercise, they were able to get through that maze faster. But what's interesting is then, of course, they euthanize the mice, and they study their brains. So they found that there was reduced amyloid beta deposition, right? So an increase of that aquaporin 4, these water channels that need to be polarized to help transport this fluid. Reduced inflammatory activation of astrocytes and microglia, which are some of the cells in the brain. So it also helped accelerate, like how we're talking about, we want this to happen efficiently. Compared to the controls, it happened more efficiently in the mice who were exercising. So exercise is not just sometimes, people think of it for their heart, which is great, but we need to be thinking of it truly, truly, truly for our brains as well. Now, one thing on nutrition is omega-3 fatty acids. So omega-3 fatty acids are found in, foods like salmon, certain nuts, avocado, things like that. And then a lot of us take it as a supplement with fish oil. So omega-3 fatty acids are anti-inflammatory, and they found that the central nervous system is highly enriched with omega-3s. Again, I feel like this is something that sometimes people just think, my heart doctor told me maybe to take some omega-3s, but they're not thinking about it for their brain, and we really need to understand how important it is for our brain. So mice on high, that's polyunsaturated fatty acid diet, with these omega-3s, right, they had increased speed of the lymphatic clearance of central cerebral spinal fluid tracer, which I'm going to show you a picture of what that means in a minute. Basically, they inject this tracer dye kind of thing into their brain, and they watch it through those imaging techniques that we talked about, where they can see the flow and they can see how fast it's moving. So when these mice were fed a diet that were high in these type of omega-3 fatty acids, they had increased function of that clearance. Also, interestingly, that these mice that I'm talking about that they engineered had increased levels of that amyloid beta, like they basically gave the mice Alzheimer's. They showed protection against neuron death, those are your brain cells, when they also had high levels of omega-3 fatty acids in their brains. So their brain cells didn't die at the same rate as their controls when those mice had all those omega-3 fatty acids in their brain from their diet. Stress. I was like, this is me right now. But stressed mice, again, exhibited decreased lymphatic influx and efflux. So that's when it comes in and it's trying to move through, pick that waste up, and carry it out. So it was slowed down because of stress, right? So chronic stress contributed to accelerated accumulation and deposition of amyloid beta. So that means the amyloid beta, that nasty stuff we're talking about that's in the brains of Alzheimer's patients, it built up faster and it deposited faster in their brains. So chronic stress raises our cortisol levels. Cortisol is a hormone secreted from our adrenal glands, and so it's active when it raises in times of stress, but we're supposed to all kind of have like acute stress, then it resolves, and then life is back to normal or homeostasis. But a lot of us are living our lives like we're under stress all the time, and that's not a very efficient way because our body wasn't really designed to deal with it very well, right? So high levels of cortisol downregulate or decrease the number of those aquaporin 4 water channels we were talking about. And also, this is a big problem right here because you guys, I hope we're talking about how important sleep is, but elevated cortisol impairs sleep quality, so it negatively impacts the lymphatic system that way, right? So if we have cortisol curve and we see that it's going up at night, or we have it high during the day, then we're not going to sleep as well, and then we're not going to clear these waste products from our brain. Okay, so here we go. All right, so those are our modifiable lifestyle factors. I want to point out a couple things on the matrix. So just something that has to do in the biotransformation and elimination category, alcohol. So after we've served you red and white wine tonight, we're going to talk about how it's not good for you. Okay, but this is something that you can see is getting a lot more attention in the research. Like, is any amount of alcohol really, safe? Well, there's been studies here that show that basically high levels of alcohol inhibit the activity, so it kind of slows the activity of the lymphatics down. Chronic high-level alcohol use results in impairment that's not easily reversed. They've been able to see that. Intermediate use even results in those, again, we're going to bring it back to those aquaporin 4 channels, but their polarization, the firing isn't happening like it should be. So that does hinder the lymphatic clearance. But good news, 24 hours of sobriety restore function in one of the studies. So, if we can take these breaks, that doesn't mean break and binge, okay, we're not saying that. But if you can take these breaks, right, it really does help the brain repair itself. So now interesting, they showed this was kind of a U-shaped curve where low-level use may actually stimulate the lymphatic activity due to nitric oxide vasodilation, so making the blood vessels more open. So alcohol may not be all bad, but we just need to be careful and understand what low use really means. It's like 1 drink a night for women and 2 drinks a night for men. Okay. All right. So now I wanted to, this is a precursor to my next slide. So I wanted to show you something about how, I'm going to talk about something next that actually hits all of these. So defense and repair, assimilation, structural integrity. It just shows you how one thing can hit all the nodes. So this is an interesting, I talk about the gut microbiome a lot, and my patients know that, but this is interesting because it's talking about the oral microbiome, right? So, but the oral microbiome is the first end of the digestive tract. The mouth is your first end, right? So basically, how could what's going on in our mouth affect our brain? Well, hugely. So this pathogen, it's a bacteria called Porphyromonas gingivalis, or P. gingivalis for short. So this is a periodontal pathogen. It's a pathogen that resides like kind of up in your gums. And it's indisputably linked to cognitive impairment and Alzheimer's dementia. It's also associated with diabetes and atherosclerosis. So in this particular mouse study, they basically gave these mice this bacteria. So they put it in their oral cavity, right? So they infected them with it, all right? They infected it with it, and they gave it to them 3 times a week for a month, all right? Then what they did was, of course, euthanize them and look at their brains again. And so they saw from a tissue standpoint that those amyloid plaques formed in these mice and did not form in controls. And the total number of neurons, brain cells were decreased, and immune reactive cells increased significantly, showing that the brain is registering that there's an infection. So also in these mice, when they looked at their guts, they found that there was gut dysbiosis, so an imbalance of good bacteria to bad bacteria, unhealthy bacteria. And it gets there because you have to chew and swallow. So anything you put in your mouth or anything that's in your mouth can definitely affect the gut, which then affects the brain. So, and then, okay, they put them through, this is a completely different journal, completely different water-based study with these mice, but the spatial memory was impaired when they were infected with this bacteria that lives in your gums, P. gingivalis. What I want to show you on the right, though, to me is fascinating. So let's not really pay, the top is just 3D modeling, it's saying the same thing, but if we look at this, these 2 slides on the bottom, so the first row is the control group. Okay, so what I want you to notice is that when they then put the tracer in so that they could see the lymphatic flow, they could see what's happening, you see in the control group, that tracer was at, so the time is across the top, 10 minutes, 15 minutes, 30 minutes, 45 minutes, 60 minutes, right? They're looking at this in those intervals, time intervals. Well, the control group of these mice, right, they've not been given this bacteria in their mouth. That tracer shows up immediately, so the influx is fast, right? Like it's functioning really quick. Okay, look, the brain takes it up, it's there. And then over time, you can see that tracer start to clear out. By 60 minutes, it's very little of the bright yellowy fluorescent green color left, correct? Right, so that shows you how the brain registered it, it was flowing, and then it cleared out. Now, in the experimental mice that just had this bacteria introduced 3 times a week for a month into their mouth, look what happened. So the tracer is slow. You don't see as much of it in the beginning, right? And then instead of clearing at 60 minutes, it's building up, right? So look at how that bacteria in the mouth, right, and your gums can really drastically slow down the clearance of that tracer in your brain. So of course they're using tracers because it can be visualized through immunofluorescence, but basically we're extrapolating that to anything that you need to waste products that need to be cleared from the brain. So again, I promise there's no quiz, but this is like why we talk about the gut and the brain so much, but there's a gut-brain axis, and this is how. So basically, without going too deep, it's this here where you see those things that look like hills. That's like the barrier of the gut, okay? And you can see where when the gut barrier integrity is compromised, then all those little things that aren't supposed to be leaking out, different macrophages and different little bacteria and things start to leak out and come into circulation. And so from down here, you can see little dots of them in this artery that's flowing up to the brain, okay? And then, so that's how it gets there. And then the other thing is, some of it gets communicated through the vagus nerve. So that's the branchy, yellowy looking thing. And you see actually what's showing here is alpha-synuclein. So alpha-synuclein is that peptide that builds up in the Parkinson's disease, not Alzheimer's. So this is how things get from the gut to the brain and why things in your gut, your mouth, your gut can have a huge impact on your brain and your neurological health. So when I'm saying, hey, are you ready to do your poop test again? This is why, because I want to make sure we have not only healthy guts, but healthy brains. Okay, so I tried to since we all speak emoji these days, right? I was like, let's just make sure that everybody understands what we're saying. So these things are bad. We don't want neuroinflammation. We can't control aging, right? These are things that slow down that lymphatic system. And then over here on the right, these are things that actually turn it up, meaning it's going to function better, it's going to flow better, all of that, right? So exercise, sleep, lifestyle choices, it's going to get those waste products out. You see amyloid beta, tau, alpha-synuclein is going to get it out of the brain. So we want to focus on those things we can control. So just a couple of things how we can help. I put one of my favorite sleep supplements up here. There's so many. There's many things. Not everything works for everybody. Some people do well with melatonin. Some people it gives them bad dreams or just doesn't work at all. So you have to kind of find what's right for you. But if you can't sleep and you have trouble sleeping on your own, acupuncture is also good for sleep. But there are certain supplements that can help you get a more restful night's sleep. And then this is, of all the fish oils out there, this is my top favorite because I know a lot of my patients will agree. We do some omega-3 fatty acid testing by blood in the office. And so you can get a number reading on what your omega-3 fatty acid levels are. And when you're below optimal, then we take one of these a day. It's got a technology that helps your body, makes it be bioavailable to your body, just one a day, and then we retest and the levels are always up. I'll say that all the time. It's like it never fails. And then for the stress component, many of you know our practice does a lot of NET or neuro-emotional technique. If you're new to us, this was a study. Neuro-emotional technique helps identify and clear negative emotional patterns that you're holding in the body that we experience as stress based on our perception of events in our lives or people, anything that's stressing us out. Even sometimes physical ailments that we might not understand maybe why they're not resolving. Lots of times they have a stress component that makes them worse. And so with NET, we can help that. This graphic is just a really quick study that was done in 2017 at Thomas Jefferson University in Philadelphia, which is the oldest medical school in the US. So they're on board with NET. The psychiatrist there, Dr. Daniel Monti, that was a moment where I was like, see, I'm approaching 50. I've known this man for like 20 years. Anyways, so Daniel Monti, he was in charge of the study, and he's now the head of the Integrative Medicine Center that they established there, and they're making all of their medical students take at least one weekend course in NET. Now, these doctors may never practice it, that's fine, but they'll at least know, and they'll know to refer, and they'll know, right? They have a PhD psychologist on board, Anna Tobia, who was actually the one who did the NET for everyone during the study. She was the clinician that actually did the NET. So you can see these were cancer patients. In a study, you just need to have a group of people that has a similarity in some way, so we're not testing people with different types of trauma. So these people had cancer, and they were in remission by 6 months at least. And so, but they had to have some part of their cancer journey that was still stressing them out, like intrusive thoughts that wouldn't go away, something that was bothering them. And so they told their story, and their story was recorded by Dr. Tobia. And then they got their brain scanned in an fMRI, functional MRI machine. What was different about this was that while they were getting their brain scanned, they played the recording to the patient, was listening to their own story and what was stressful to them. And so you can see that the part of the brain that was lighting up, that's on the bottom, that's before NET. There was signal uptake in the parahippocampus and the amygdala. So these are parts of the brain that have to do with memory formation and stress and emotional regulation. So then what happened is they got up to 5 sessions of NET. They worked with Dr. Tobia, and then they went back and they had their brain scanned again, and they listened to their same recording. It's their story. And so afterwards, they found that that signal was significantly reduced and gone altogether in several of the patients. So basically, they're showing that there's a physiological change that's happening in the brain. The stress is the same, the story is the same, right? The journey is the same, but the emotional upregulation that was happening where they just couldn't cope had markedly decreased. Then there is as far as the oral and gut microbiome go, there is a lab that we use called Oral DNA, and they basically do this test, and it's called My Periopath, and it's a 30-second swish and gargle, and it looks for the bacteria in your mouth for different, the DNA of those particular bacteria. So one of them is P. gingivalis, so you know if you have that particular bacteria, if so, what your levels are, and then, discussion of what to do about that. 11 types of bacteria altogether. And then there's an add-on test that measures this inflammatory chemical called interleukin-6. It's an inflammatory cytokine. So it just is kind of an additional thing that tells us, well, how much inflammation is really going on in your mouth, right? If your gums are bleeding at all when you're brushing your teeth or flossing, then this would be a good test for you to have, right? That's not a prerequisite. Anybody can do the test, but certainly there's a gingivitis likely happening there if we're getting any bit of that happening when we're flossing or brushing. And then my favorite functional medicine test, the GI map. So this is a qPCR test, quantitative PCR test, that looks at you. It's an at-home stool sample, and you mail it in. You collect, and then you mix it with this little solution, and you mail it off. And then we get the results in about 2 to 3 weeks. And so it looks at the levels of not only pathogenic bacteria, also opportunistic bacteria, which by itself may not be bad. It just means, is there any of it that's really kind of taking over, or it also measures the level of your healthy bacteria, your lactobacillus, your bifidobacterium, and some of your other ones that need to be grown by prebiotics, right? So it looks at that to see kind of what's the microbiome of your gut look like, and is the balance where it should be. Also, it looks at some gut immune markers, inflammation markers, and there is a marker on there for intestinal permeability. It gives us, it's an indirect marker, but it's a good kind of cast a broad net to say how's the integrity of that gut barrier holding up. So, and the good news about this test is it is indeed covered by Medicare. So, I think that might be my last. Oh, no, gosh, I almost forgot about my favorite rat study. Okay, so this is a therapeutic intervention. So again, not a modifiable lifestyle factor because you can't do this to yourself. You can't change this on your own. But this is how electroacupuncture can help that lymphatic system. So this was the study where they were like, we took out the dumb mice. So anyway, what they did, these SAMP8 mice, those are the mice, that's what they call them in the research for the mice that have been given this Alzheimer's condition. Okay, so they had those mice, and then they had age-matched controls. So, and they compared what happened here. So this study was done over 8 weeks, and basically the electroacupuncture group, that's the actual mice and them getting acupuncture right there. So they put them in these little fixator boxes, and they give them needles. There's 3 needles in these mice. So, and they stimulate them, they put the electroacupuncture current on the needles at 2 hertz, and these 3 points are chosen, do 20 yin tong. Well, those 2 points are getting needles 10 minutes a day, 1 time a day, for 5 days in a row. So 5 days in a row, and then for the other 2 days of the week, they take a break. And then that is repeated for 8 weeks. And then at the end of each acupuncture session, there's a point. So do 20 is here at the very top crown of the head. That's do 20. And then yin tong is the point right between the eyes. I know my patients know this point really well. And then there's a point right here above in the philtrum, above the upper lip. That's do 26. So it doesn't typically get needled, but what they do is they'll prick it. They use the needle that they were using in the study, and they just pricked the point 10 times, okay, for these mice. And then why did they pick these points? This is where we get a little Chinese medicine theory here. So this due meridian, it starts in the perineum and is said to kind of flow up through the spine, the spinal cord, and then kind of influence the brain, and then ends right at that point, okay? So these points regulate the spirit, calm the mind, awaken the brain, activate the collaterals, and open the orifices. So that's how we learn it in the flowery Chinese medicine lingo. But you can kind of see like why these points were chosen. This is the theory about how these particular locations work. So again, there's that water maze. They put these mice through the water maze. They also euthanize them and scanned the tissue of their brain and looked to see kind of what was going on there. And they also looked at it under MRI and immunofluorescence to look for amyloid plaque, and they also studied those aquaporin 4 channels. So here's the results. So basically the electroacupuncture worked in many ways. It improved learning, so they learned the maze faster, that preserved memory, and then it alleviated neuronal injury. So these mice that got the electroacupuncture had more of these Nissl bodies in their brain, which is a good thing. And they had reduced accumulation of amyloid beta compared to controls. So they did not have as much amyloid in their brain, even though they were these aged mice that had been given Alzheimer's, basically. So you had 3 groups, let me just say that. So you had an age-matched control that did not have the Alzheimer's, okay? I'm gonna call it Alzheimer's for lack of a better word. So you had an age-matched control that didn't have the Alzheimer's. You had a mouse that had been given the Alzheimer's but didn't get the acupuncture. Then you had the mice with the Alzheimer's that got the acupuncture, okay? Those are your 3 groups. So what you can see here is something similar, is this tracer clearance was a lot faster in the electroacupuncture group than in controls. So these mice down at the bottom, so if you just look at this left-hand column is your normal age-matched mice, but they did not have Alzheimer's. The middle group is the mice with Alzheimer's that didn't get the electroacupuncture, and the third group got the acupuncture. So even if you can just look at that bottom slide at 50 minutes, you can see the far left and the far right look fairly similar. You're looking for the white. You're looking for the white coloring. That's the tracer still there in the brain tissue. The middle one is the Alzheimer's mice that didn't get the electroacupuncture. And you can just basically see that you've got more of those white streaks still evident there. Okay, so we can see from that study that the electroacupuncture helped clear that amyloid, or the tracer out of the brain, even in the presence of Alzheimer's. Okay, and then so the aquaporin polarity was also increased, and that's basically just telling you that the polarity was happening like it should be. So, I think that does it. So that one there we go. So I'm hoping that everybody can take away from that we really just want to do what we can, and the research on this is going to continue to evolve, right? Something that's only 10, 11 years old in science is in its infancy. So we'll continue to learn more about it, but hopefully you guys have some take-home points of how important this is and how important sleep is, and anything that you can do to improve that, and we can help you with. We're here for you. All right, we're going to do the drawing. Okay, so is this for let's do the detox kit first. Now I have to put my readers on. All right, so the last 4 digits, the whole number is 456089. 089. Oh, yes! Okay. So who's bringing up the detox kit? Chelsea? You grab it. Right up here at the front table. All right, so this one's for the Prolon kit. All right, 456098. What? That is my yoga teacher. So. I know, now you're doing it. See there, the universe is speaking. All right. Okay, great. So we are so thankful that you guys came and enjoyed this. We look forward to hopefully doing it again next year now that we're out of the woods. Thank you for coming.